Well, hello, kiddos. It's been such a long time. My pre-calculus class, how I've missed you so much. Man, welcome to my humble abode. Check out my new whiteboard. I got it just for you so that learning can just continue to happen because I know how much you guys just love your maths. Anywho's, looking at your Khan Academy completion rates, it looks like about half of y'all got it done, which means like half of y'all are struggling. So I'm just going to create some more videos to help support you guys with Khan Academy. This is for that first assignment, so it's lesson 1, assignment 1, continuity at a point, graphically. So that's what this video is about. Let's check it out. All right, so first let's review one thing, a limit. What is a limit? What does it mean for a limit to exist? For the purposes of this video, let's say that it approaches the same value from the left as it does from the right. So if you look at it at the, if you trace it from the left and you trace it from the right, if they go to the same point, you say the limit exists. All right, you're gonna need that to know this understanding. You're going to need to have this understanding of a limit in order to master this topic of continuity at a point. All right, so this is what's new: continuous at a point. So if we want, if we're trying to figure out if a function is continuous at point A, there's 3 things we're gonna look at. 3 things. First, the function must exist at A. So if you're trying to figure out if the function is continuous at point 4, if you plug in 4 into your function, you have to get a number out. It has to exist. Second, the limit as x approaches A must exist. And we already talked about what that means as far as a limit needing to approach the same value from the left as it does from the right. And then finally, these 2 must be the same. So the function evaluated at A must be the same as the limit as x approaches A. These 2 must be the same. So let's look at an example. All right. Look at this graph right here. This is function. It says function g is graph. So here's function g. A little funky. I'm gonna just trace it real quick. There's a little hole right there. It's an open circle. All right. It says select all correct statements about g at x equals -4. Now some of you guys were confused about all the letters, the variables. So it says continuous at point A. In this example, A is -4. It says x equals -4. So we're trying to figure out if this is going to be continuous at -4. Choose all answers that apply. Part A, it says both the limit of g of x as x approaches -4 from the right and the limit of g of x as x approaches -4 from the left exists. Let's see. I'm going to first check out approaching -4 from the right. So as I approach -4 from the right, what value do I get close to? Right here with the open circle, that value is 1. Can you see that on the camera? Sweet. All right, so this exists. The value is 1. As I approach -4 from the left, I'm going to just trace it again. I also get 1. So yes, I'm going to click A. Let's click A. Because both the it exists from both the right and from the left. Part B, it says the limit of g of x as x approaches -4 exists. Now remember, in order for this limit to exist, it needs to approach the same number from the right as it does from the left. And we just saw in part A that if you trace it from the right and you trace it from the left, it goes to the same value. It goes to 1. So yes, the limit actually exists. So I'm going to click B. Part C, it says G is defined at x equals -4. Let's see. So here's my graph. Is it defined at -4? No, it's not. So right here at -4, you have an open circle. An open circle, meaning there is no value for y when x is -4. So no, it doesn't exist. So I'm not going to click C. Now D. G is continuous at x equals -4. Now, let's bring it all together. Is it continuous? If I can bring your attention right here to continuity, you want to figure out if it's continuous at -4, then f of a exists. We plugged in -4, it was a hole. It doesn't exist. We put an X right there. I already know it's not continuous because this wasn't true, but I'm still going to go through the rest. Did the limit exist? Yeah, we said the limit exists. The limit was actually 1. Because from the left it went to 1, and from the right it went to 1. So yeah, I'm going to put a check. Are these two the same? Were part 1 and 2 the same? This was 1, and this one did not exist. They are not the same. So I'm going to say that it is not continuous. So I'm not going to click D. And none of the above, obviously that's not an answer. So I'm going to check my work. Whoa, great job. We did it. Hey, math. All right.